we have we can characterize a line um, by an equation. So if my line is horizontal, so an horizontal line, so I can imagine, for example, I have a line here, let's say position 2, approximately. Let's move it down a little bit. So we have, let's say, 2 here. So any point on this line has any point, so I can um, has y, like the second component is of my point is an x here, okay, an x, and the y is the same, okay, because the distance to the x-axis is always 2. Okay, so any point, so all the points on the line can be characterized by an equation like that, y equal to, okay, horizontal line, more generally, so we will say it's a y0, okay. Um, yes, so let's just erase this part, write it y0, okay, or b, or let's call it b so that we connect with the later what are the other notations, okay. Now, a vertical line, this is an horizontal line. Let's say, okay. So the equation we will say y equal to a vertical line would be something like we understand it, something vertical. Yes, I will have something like that. So if my uh, line, this set of points crosses the x-axis at the point with coordinates x0 and 0, then any points here will have something x0 and some y. We can read the projection as a y. Okay, some y here. Okay, y0. So what is but they have this the same uh, and they have all the same first coordinate x0. Yeah. So we can characterize this set of points by x equal x0. Okay. The whole set globally is characterized by x equal x0. Okay. Yes. Okay. Okay. Now a line that is not horizontal or vertical. Okay. A line uh, so that is non-vertical or in general, so will be that is not more that is not, so we specify that is not vertical, we will see why, is described by an equation like y equal mx plus b. Okay, mx plus b, we call b the y-intercept, b is the y-intercept, so it's the value we obtain when x is 0, okay, and m is called the slope of the line, okay. So when m in particular, m equals 0, if you take m equals 0, you have an equation y equal b. So you have an horizontal line. Okay, we have an horizontal line. Okay, so mainly this is what we have to, um, yes, there's three situation we need to be aware of. Okay, so let's go through some exercises. Yes, explore different kind of questions. Okay. Okay, so let's do the first question. Question one. For example, you are asked uh, to find the equation of the line. Find the equation of the line of the line with slope 2 and y-intercept minus 4. So here the answer is easy. Okay, the answer is easy because yes, so that's the answer. So we know we have, since they said slope, so we have okay, we have equal to, and I know b equal minus 4. Then the equation will be 2x minus 4. That's all. Okay. Okay. So this is what we saw just now. What if we were asked the following question? Find the line passing through. Find the line passing through the 2 points, passing through A with coordinates 2, 0 and B 0 minus 4. Okay, great. So at the same time, so here, knowing 2 points, I know my line. I can sketch my points. For example, 2, 0 to have an idea here. Here is A, 2, 0. What about B? B is 0 minus 4. 2, 3, 4. Okay, minus 4. So here is B with 0 and minus 4. So I can join my two lines by my 2 points by a line. Okay, here it is my line. Passes through the 2 points. Okay, approximately. Okay, we have done our graph here. Here is my line. So this my line that is not vertical, so it has a slope. So I know, so my line, my will have a general equation like mx plus b. So my ya is uh, verifying the equation since it's part the point is part of the graph. So it's a plus b. I can do the same for b. Yb will be xb plus b. Now, why I'm doing this? So I want to identify the slope m. The way to do it, I can subtract the two equations to eliminate b. So if I subtract, I do 1 minus 2, I will get ya minus yb equal m xa minus mxb, and b are constant. Then I can factor it xa minus xb. So finally, my slope m is just ya minus yb over xa minus xb. And this formula is always true. You can use it for when you have a line passing through 2 points. You have always any 2 points from the line. You have a slope is the same and remains unchanged. Okay, so this is important, and here we are reviewing it. So m it will be then ya is given is 0 minus yb is minus 4 over x of a is 2 minus x of b is 0. So it will be 4 over 2, which is 2. So I have my slope is 2. What about b? Once I had b, I can deduce b. B would be, for example, let's use b, the point b, because the xb is 0. For xb equals 0, we have yb, it is equal minus 4. So we will have m times 0 plus b. Then b will be minus 4. Okay, so like that, I have my equation. So the equation um, is given by y equal the slope to the slope 2x minus 4b, and I have my equation. So it was the original equation we found. Okay, So what about now if we were asked to sketch the graph? Here is another question. Sketch the line, sketch the line with equation 2x minus y minus 4 equals 0. So here the equation is not given in the form y equal mx plus b, so that I can identify the slope, and we can either choose 2 points, just we can choose 2 points to graph the line, okay? Choose 2 points, okay? So usually we choose simple values. We choose x equal, for example, 0 and deduce y. So I will get y equal minus 4. If I choose y equal 0, I will get x equal 2. And I have my 2 points. Okay, the b, this is my b, and this is my a. So it's the same line. I can also um, write the equation, write the equation in the form y equal mx plus b, which is here easy. So here it's y equal 2x minus 4 again. Okay, so we have the same line. This is my line y equal to x minus 4. Okay, so we can now completely align given a slope and a point, or the y-intercept, or given 2 points. Okay, or given the equation, we can deduce points, particular points, identify the slope and the y-intercept.